is the following table proportional? And the directions for this one also said that we would need to show our work to earn full credit, and it says showing your work includes long division in this example. I can tell, since I'm going to be using long division and its decimals, that I'm going to need room. So I grab this hand tool, which is the panning, so I can move the objects around, and I'm going to just kind of push that over so I have lots of space over here to work. And then I hope you noticed that I already labeled the x's as the top row, time and seconds, and then the y values are this bottom row. So check that work first on your paper. Then I'm going to use the scribble icon, and I'll pick a different color, and I'll fill in the unit rate formula. So k equals y over x, we just write y over x for short. And in this first point, the y is 8.41. You gotta be very careful with this kind of horizontal table because it's opposite. X is at the top, up here, but this x.2 needs to go at the bottom in the formula. So this is y over x, the table shows x and then y, so just be careful. Now I need to use long division. So remember, the numerator goes underneath the division symbol. So it's 8.41 divided by, and then the denominator goes on the outside. And I can write 0.2 or 0.2, same thing. When I'm dividing decimals, the only number I have to check is the number on the outside. That's the one that if it contains a decimal, you have to get rid of that decimal. So it does contain a decimal over here on the left, so I need to move it to the right one time. If I am moving to the right one time, moving to the right one time basically means I'm multiplying it by 10. 0.2 times 10 gives me 2. So I move it over once. Well, if I move what's on the outside, the decimal over once, I have to move the decimal over here over once. Basically, if you multiply the denominator by 10, you have to multiply the numerator by 10 to keep this ratio the same, to keep this fraction equal to the new fraction. So I move this decimal over once and it becomes 2. And then the decimal ends up between the 4 and the 1. So I'm going to write 8, 4, and then the decimal and then the 1. And I'm going to go ahead and bring that decimal up to the top. And then I can start asking the question, 2 goes into 8, how many times? Well, that would be 4 times. And the answer to that question goes at the top. 4 times 2 is 8. The multiplication goes underneath the 8. You subtract it from the 8. And I get 0. I cannot ask the question again until I bring a number down. 2 goes into 4 twice. The answer to the question goes at the top. The multiplication, 2 times 2 equals 4, goes underneath the 4, and you subtract it from the 4. I'm left with 0. I cannot ask the question again until I bring a number down. So now that I've brought a number down, 2 goes into 1, well, 0 times. Then I multiply. 0 times 2 is 0, that goes below. 1 minus 0 is 1. And I'm going to have to add a 0 because I have a remainder, and I need to continue this decimal. 2 goes into 10 exactly 5 times. 5 times 2 is 10. I subtract, and I have a remainder of 0. So I got 42.05 for the unit rate. Let's check our next point. So again, this is where it's so important that you're careful. The y is 1.682, and the y goes in the numerator. So 1.682, and then I carefully check x is 0.04, so x I put here, 0.04, which is the same thing as 0.04. I can write it either way. Then remember, the numerator goes underneath the division symbol. So it's 1.682 divided by, and this denominator goes on the outside. When I'm working with decimals, I only have to check the number on the outside. If the number on the outside contains a decimal, that needs to be fixed. So I'm going to move the decimal twice to the right, to get rid of that decimal. So I also have to move this decimal twice to the right. Moving twice to the right is like multiplying by 10 and then multiplying by 10 again, which will be the same thing as multiplying by 100. And if you multiply the denominator by 100, then you would have to multiply the numerator by 100 to keep the fraction equivalent, to keep this ratio equal to this ratio. So that's why when you move this decimal, you also have to move this decimal. So on the outside, we end up with 4, and on the inside, the decimal ends up between that 8 and the 2. And I'm going to go ahead and bring that decimal up to the top so I don't forget about it. 4 goes into 1, 0 times. 4 goes into 16, 4 times. 4 times 4 is 16. The multiplication result goes below and we subtract it. I cannot ask the question until I bring a number down. Now I can ask, how many times does 4 go into 8? The answer to that question is 2, and it goes at the top. 2 times 4, the multiplication, gives me 8. That goes below and I subtract it. Can't ask the question until I bring a number down. 4 goes into 2, 0 times. 0 times 4 is 0. I subtract. I get 2. I need to add a 0. 4 goes into 20 exactly 5 times. 5 times 4 is 20. I subtract. And I finally got to a remainder of 0. And guess what? The unit rate is the same. Well, if the unit rate is the same throughout, that means that it is a proportional table. So is the following table proportional? Yes, because the unit rate was the same throughout the whole table.